This video summarizes the Math 1 lesson titled Prove It. This is a practice understanding task. The purpose of this lesson is for students to use slopes and lengths to classify shapes on a coordinate plane. So in this video, let's start with number 2. We want to determine if quadrilateral ABCD is a rectangle and explain how we know. So the first thing we need to know is, well, what does it mean to be a rectangle? A rectangle is a quadrilateral with 4 right angles. So what we need to do to determine if quadrilateral ABCD is a rectangle is we need to see if it has 4 right angles. Since this rectangle is on a coordinate plane, we can check for right angles by checking for perpendicular segments or opposite reciprocal slopes. So let's find the slope of each of the sides. So give from D to A, I'll go down 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4. So the slope here is negative 6 over 4, which would simplify to negative 3 over 2. The slope from A to B, we go up 2 and over 3. When I compare segment DA to segment AB, then I do have perpendicular segments here, so I have a right angle. All right, let's check the others. From B to C, we'll go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. The slope of BC then is negative 6 over 4, which simplifies to negative 3 over 2, which is an opposite reciprocal to segment AB. Then from C to D, I'll go down 2 and then over 3. So my slope is a positive 2/3. 2/3 is opposite reciprocal to negative 3 over 2, so I know that I have right angles. So yes, this is a rectangle, and I know because the adjacent sides have opposite reciprocal slopes, meaning that the adjacent sides make 90-degree angles. And since quadrilaterals with 4 right angles are rectangles, then quadrilateral ABCD is a rectangle. For number 4, we need to determine if ABCD is a square and explain how we know. Well, squares have the properties of the rectangle, which is a quadrilateral with 4 right angles, and it also has the same properties of a rhombus, which means that all of the sides have to be congruent to each other. The squares are quadrilaterals with congruent sides and angles. With the congruent angles, each angle has to equal 90 degrees. So let's take a look at this quadrilateral. Let's start with looking at the lengths of each side. I'm going to use the distance formula to find the length of segment AB. With the distance formula, all I need to do is substitute in the values for x sub 1, y sub 1, and x sub 2, y sub 2. Now I simplify what's in the parentheses, then square what's inside each parenthesis, add my 2 values, and then take the square root. This means that the length of AB is 8 units. Now I'm going to calculate the length of BC to see if it's the same. After substituting in the values, then I'll simplify what's inside the parentheses, then I'll square what's in each set of parentheses, add, then take the square root. This means that the length of BC is also 8. Let's check CD. So I know that the side length CD is 8. So the length of DA is also 8. So all I've done so far is prove that this quadrilateral is a rhombus. To prove that it's a square, I need to also prove that each one of these angles is a 90-degree angle. So I need to check the slopes. So the slope, we'll start with DC. I'll go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7. So this slope is 4/7. From C to B, I go down 1, 2, 3, 4, 5, 6, 7, and over 4. So this slope is negative 7/4. Those are opposite reciprocals, so I have a right angle. This slope is down 1, 2, 3, 4, then over to the left, 1, 2, 3, 4, 5, 6, 7. So that's a positive 4/7. making these opposite reciprocals. And then this one's slope will be down 7 over 4, so that's negative 7/4, confirming that these last two angles are 90-degree angles. So this is a square, and I know that because each of these side lengths measure 8 units. So it does have congruent sides. And it also has congruent angles because all of the angles are 90 degrees. And I know that all of the angles are 90 degrees because I found their slopes. The slopes of DC and AB are positive 4/7, and the slopes of CB and DA are negative 7/4. Since 4/7 and negative 7/4 are opposite reciprocals, then I know that the segments are perpendicular and form right angles. We've gone over 2 of the problems in this task, but there are others that ask you to classify different shapes. For all of these problems, you need to either use the distance formula or find the slopes, or do both. So for a parallelogram is a quadrilateral with opposite sides parallel and congruent. So to determine if a shape is a parallelogram, you can use the slopes to check to see if the opposite sides are parallel, or you can use the distance formula to see if the opposite sides are congruent. For a rectangle, we used the slope formulas. We looked at the slopes to determine the right angles. For a rhombus, we would have used the distance formula to make sure that there were congruent sides. For a square, we had to use both the distance formula and find the slopes to make sure they were opposite reciprocals. For isosceles triangles, to make sure that 2 sides are congruent, you're going to need the distance formula. For equilateral, to make sure 3 sides are congruent, you're going to need the distance formula. And for a right triangle, you'll just need to find the slopes. Compare the slopes, make sure they're opposite reciprocals. And that is all for this video. Thank you for watching.